Alright guys, let's continue where we left off in the previous video, which was this part in the array stuff. And I think we're not gonna spend too much time on it. I'm just going to add it for now. So here we have that, and that's it. We're not really gonna go through this. We'll see how it works later on. Now let's get into the actual kind of equation we're going to be solving, and I think I will read this and then we will talk about it. All right, so the first step is to make some kind of description of the data that we're working with, which is like these two concentrations. UAV are like some kind of chemical thing. You can think of it like that. That's what it's supposed to represent. And let's make a new file here, a new module, I guess it's called. And we will do like this. And here we go. So first we'll define which floating type we use, so we can, we'll always refer to float instead of anything else, instead of like the specific type. Then we can change it out, I guess. It's nice. Then we need the UV struct, I think, and we can call it UV, like that. It has a 2D array of floats, and another one. So now we need to use empty array. Right. Then we have some implementation of this guy. We have a new, which has a hard-coded pattern. Actually, I'm just going to copy this, I think. That will make my life easier. Let's make it public. So what this does is it sets up a world with some number of rows and columns, and then basically in the middle of this world it puts in some so this function here returns 1 in the middle of the world and 0 elsewhere, and then the U chemical is 0 in the center and 1 everywhere else, and the V is the opposite. Great. Then there's also a way to create nothing. Okay, I need to fix this. Be right back. All right, I think we're good to go. So we have the zeros here. It just creates a bunch of zeros, and then we have a shape function, which just looks at the shape of you. I mean, they should be the same, and the only way to construct things is unless you do it manually, is in a way such that they will have the same shape, so that should be okay. Then double buffering. So we are going to continuously update these things, and you cannot update them in place because of the way the algorithm works. So what you could do is you could allocate new arrays, then fill in new values there, and then use that. But we don't want to keep allocating things, so we're going to use this double, we don't want to allocate things every iteration, so we're going to use this double buffering pattern, where you just, in the beginning, you allocate 2 copies of everything you need, and then you switch between those. All right, so let's make a new one, file we call concentrations, and it's going to have this here, concentrations, I think, and there will be some buffers, 2 of those, and source is 1 boolean. Okay, so we need to use create UV, so we have that, and then we can implement concentrations And what do we need? So maybe we will just copy this stuff, because I don't think this is the most interesting part of what we're going to be doing. I'm going to remove the comments. And let's go ahead and add it in here. Yeah, there's definitely some issue with my setup right now. I'm not sure why. All right, here we go. Great stuff. So we have the new function, just creates 2 buffers. And then we have the shape, which looks at the first buffer. That's fine. We have the current one, where we access this buffer's array based on the Boolean. Here we go. And then we update. So this is kind of interesting. It takes a function that takes a reference set of concentrations or like the starting one, and then the one it has to write into. You can see that because it's mutable. And then basically call that function, and you flip the Boolean. All right, great stuff. And this, so we have this object, and it can be used to run a simulation like this. First you create something, some other stuff, then you run for some number of steps, I guess, and each step you call this update thing. Here this one is not doing anything. All right. HTF5 output. Now we need to be able to output our stuff some way. We can try to use this HTF5. Let's see if we can even add that. So it seems to work. And let's make a new file like that, where we'll have our HTF5 writer, like so. And it has a file, which is a file, and it has a data set, which is a data set, and a position, which is usize. So what is all this stuff? It could. So let's actually add it to the crate. Like so. And now we should get some help here. So HTF5 file, okay, it's from that, for the data set as well. Right, yes. So we have those. Now we need the annotation block. And again, that's a lot of kind of not so interesting bookkeeping code. So we are going to add that like so. So first you create a writer. First you create the file, and then the data set you create it like this. Oops. Apparently, new data set of floats, chunk, like that. All right. And the shape is the number of images. What does that mean? Who knows? But okay, so you create it like that. And how do you actually write? You give it a So you tell it how many images you want to write, and then you write an image one at a time, and an image is this UE thing. So let's try to run that. So here I want to say use HTF5 writer, and also use UV. So this stuff think we don't need. Let's go ahead and say our UV is just some zeros. Oh, we can say new, and we need the number of rows. Let's say 10 by 10. Then we need a rider. Probably it has to be mutable. So it has to be mutable. HTML5 rider, new, and what does this take? No, it was create. It takes a string. So we're gonna just do it like this. Don't know what the extension is, but something like that. And then we have create number of images. Let's say 2. Why not? And then we can say rider write. Thought we could. Let's go ahead and check this. Okay, so it should be possible. It's because this might fail. Okay, so we're just gonna unwrap it. Now we can say write, which takes self and the UV by reference. And interesting that this is not in the drop trait. So actually we could do something like this, implement drop for HTML5 rider. And this, we're missing a function fn drop, so here we go. And in this one we can say self file close. Then we don't need this one. Of course this can fail, I suppose. So we should make sure it happens. Couldn't close HTML5 file. Like that. Alright. So we can even try to write it twice, and go run. So it failed. Let me try to figure out what's going wrong. Right, so after Googling around, it seems like this HDF5 crate might need an older version of ND array. So I actually think we are not going to do that. Let's go ahead and delete this one. So what we're going to do is maybe in here we'll have a write to file function. And basically I want to create just an image. So let's add the image create. And we need to use now image. There should be some kind of write buffer with format, image encoder, image reader. How about let's try this one. Anyway, let's have a function here that says write something, write to image. It takes self, and maybe it takes a boolean that decides whether they want to write U or V. Let's actually get rid of that one now. So U or V, which one? Let's do use U boolean, and there might be a result or something. We'll see about that. So let's first just try to create an image. So let's first decide which array we want to use, and if we want to use U, of course it's like this, and I guess we take a reference, otherwise now we should have a reference to an array. Now I want to create some kind of image, and since these are just 2D arrays with numbers in them, maybe let's just create a gray image for now. Maybe later we can do something where we combine the two. One is like red and one is blue or whatever, but for now let's do it like this. All right, so a new one, and it takes width and height. So we need to figure out what the width and height is, which we can do like this. It's height and width actually. Get it like this, but here we have to say width first. All right, so now this should give us a new thing. This is the image, and we want it to be mutable, I guess, because what we want to do is now, can we loop over it somehow? So let's actually, okay. Is there some kind of a way to iterate? We can iterate it. How about something like this? And this will just iterate pixel by pixel. And we also have some kind of parallel thing, which I guess is noise. All right. Let me think. So let's actually get the zip construct. The zip construct is kind of nice, even if you don't want to zip things. But let's try something like, I'm not super into it. Let's see what we have. Let's try from the array, and this takes some other thing. We can try to say image, and we need the pixels mute. Is this something we can do? Will this compile? The trait bounds. Okay, so this doesn't really work because this only works for arrays, I think. So that's fine. Let's do this one instead. So here we have that. There's no, this is maybe a result or what? No. Enumerate pixels mute. But it has no methods. Can we do like this? So this is indeed an item, and I suppose it's supposed to be an index and a value, and that did not work. It's not an iterator, even though it says enumerate. And there's nothing here. Okay, whatever. So pixels mute. This is an iterator, and actually I want to enumerate. I can also enumerate rows, but whatever. Let's do this. Now we have an index, great, and a value, but okay, so actually we need something like, I suppose maybe row and column. Is that correct? It really yields the coordinates of each pixel, but what does that mean? What does that even mean? Iterator next. So what does this return? Pixels next map. So X and Y. So it is X and Y. So that means it's column and row. Great. And this is a reference. So what we can do is we should be able to do something like this. Write into that the value of array, row, and column. Like so. just like that. Okay, do I have to say as your size? Right, and this thing is a float, but this one wants a U8. So that's great. What we're going to do is multiply it like this and convert it to U8. Actually, we should probably, just to be sure, let's clamp it to go between 0 and 55. And it wants also an array, so we can give it that. This. All right. And this one doesn't want U size, it wants U38, whatever. Okay, so we kind of like just copy all the data over, and that should be fine. Then we need to write it. So I suppose there might be like a write to, writes the buffer to a writer in a specified format, writes the buffer with the given encoder. So that means we need a writer. What is a writer? Image writer. Still only have that. Save buffer. Okay, this is maybe more. Not really, honestly. All right, let me Google it. All right, there's just the save method, which I don't know why I didn't try that. Well, let's do it like this. And this is a result, so we'll just well, let's do it like this. And it returns a result of nothing or an image error. Great. All right, back to the main file. This is now no longer a thing. And we're going to create a UV, and then we're going to say UV write to image. And here we'll say true, and we will just unwrap that. Great. Now we can try Kako run. And let's see what we get out. We got something out. And we have a very small image up here, which is, I have to do these weird like set, I think. This does not look correct, honestly. I mean, I thought it would be more like in the middle. So here we have row is greater than, this is basically half, like 7 divided by 16 is half. Row is less than this. Column. Maybe there's an issue here. Row and column. And this should also, this is a Boolean, so this should be 0 or 1. But it's not, it's a weird thing there. Okay. Let's try somewhat bigger one. Maybe there's some kind of weird rounding thing. Okay, this looks more correct. This looks more correct. So here we have like a blob in the middle. Okay, great stuff. And if we write this one instead, actually we need to run it and then we check it. Now we have a kind of inverted image. So that is what we want. One thing we do need is to say what is the path here. this like common pattern when you want to save things. You say it's just something where P is something that can be turned into a path like that. And then we're going to use that path here. I think this one should have the same trait bound. Indeed it does. All right, but if we now go here, we should say, okay, test. And that just work. Okay, so what we can do now is we can write the results to an image. Great. Now there's this reusable simulation skeleton. We have a bunch of options. Let's grab those. And I think we'll keep them in the main for now. I don't want to keep all these comments. Like this. Then we have our run simulation function. We'll need to update that a little bit. But all right. So whatever. Let's say actually. Yeah. Okay, get rid of that. We create some concentrations. We don't use HDF5, so let's get rid of that. Then we do this stuff. And this one, get rid of that. Well, maybe, okay, it's going to return a result of something, or let's say image error. Like that. We need to import the concentrations. There we go. We have that. Nothing like this. Okay, so what we want to do is, let's return okay, get to here. We want to save the image every time. So I think we're gonna keep this one. We're gonna have the file name for you is going to be just format this thing. It's going to be you, and then we'll have something like this, four leading zeros. So when we sort it later with bash utils, it's going to make a lot of sense. And this one be B. And what we're going to do is we're going to say concentrations dot current, write to image, file name u, and actually I want to do something else. I want to go here and I want to say maybe this is just like which, and it's going to be a little bit weird. We'll do something like this. So there's no doubt, and this one should probably need to derive partial eq. Well, never mind. So this one is now going to be match which, and if it's a u, we'll say just okay, self.u, and otherwise like this. Okay. I kind of think that's a little bit nicer. So here in here we can say, let's get rid of this one actually. Put to do. And this one is going to be which you, like this. And this might fail, so we're going to do that. This one like this. Okay, so it's telling me I can do this. Great. So the way it works is we start up some concentrations, then we loop for some number of outer steps, some number of inner steps. In each inner step we update, and then we save it. Great. So we could try to run this, and actually I think this is probably something we want to make customizable later, but let's make like a data folder that contains data, and let's just try to run it now. So let's say this one we need. Okay, so let's say options equals runner options, and we need some stuff. So we need number of rows, let's say 100, number of columns 100, and number of output steps, let's say 2, number of compute steps rather, let's say 3, why not? So there we have that. Then we can say run simulation with these options. And what's the update function? And anyway, the update function has to take the current and the next, has to do something. So right now I'm thinking maybe just next u is equal to current b, x3 equals current u. Great stuff. This one has to be like that. And okay, we can do that. So can I say like assign from? Okay, so we'll do that. Again, it's not this one, it's supposed to be u. All right, and these have to be borrowed. Great stuff. And this can fail, so we're just gonna unwrap it. Great. Let's try to run that. Cargo run. And it finished running. And in here we have some images. And if we go into data, can we do diff? So let's try to diff this one with this one. They should be exactly the same. On the other hand, if I do this, they are different. Great. So that works. This kind of stuff, maybe it's not so nice. Like that's why you would want to use HDF5, but I don't want to downgrade NDArray just to do that. And yeah, it's not so nice because we have to do IO in each iteration. But it is what it is. And it isn't what it isn't. Next thing, which I think is going to maybe be the last thing in this video, because it's already been a while, is to make this stuff customizable from the command line. And what we're going to do is add clap command line argument passing with the features derive. So there we go. And now we can go and say use clap args. And we turn this runner options now into some args. Great stuff. And then we need to do all of this. So I'm actually going to do this. Sorry, like that. And I'll remove all these pointless comments again. So this one we don't really use, and there we go. Pretty big default size. I don't know why it's not square, but that's fine. Then there are some other options here that we're gonna need, I guess. Let's put those in. Here I will keep the comments, and we don't have the float. We need to import that. And then we create this thing. So this is the final the main interface, which contains both the runner options and the update options. Put this guy up here, like that, and whatever. We'll keep this up because I think if we now go and say cargo run and we pass help, it should do something smart. Okay, it doesn't. No such file or directory. Because I'm running from in here. So actually it didn't really try to pass anything. So what we need to do is we need to say options is options pass. And that just works. But here now we need to say options runner. Now if we do it, okay, we get some bunch of help, and we get here this text that is up here. So that's pretty cool. That's pretty neat. All right. So I think let's get these constants in as well, because I'm just going to copy paste them. And just to keep things a little bit clean, I'm going to put it in here. So let's go to lib and we say, actually now we have another thing called consts. And this one needs to then use create UV float. Let's check that it still builds. It does still build, so everything still works. And I think that's going to do it for this video. So we are basically, okay, fine. Let's do this last thing. Decative. So this one is kind of fun. What we can do is we can say, let's keep it. We can say, give me a progress bar. So indicative progress bar, new, and how many steps? Let's say 100. Then we can say for I in 0 to 100, progress dot increment 1 and progress. So do we have a sleep? Maybe thread sleep. How many? What is the so duration? So we're gonna say duration, maybe time duration from seconds, and let's sleep like this much. Actually, it's a bit too much. So this will take half a second to run. Maybe that's, sorry, it will take 5 seconds to run. So that's okay. Now we can see how it works. It gives us this nice progress bar, as you can see. Bam. Very, very cool. So we can use that up here like this. Get the progress bar. We are just gonna increment. And actually now it's not 100, right? It's just number of output steps times number of compute steps. What's it complaining about? For some reason, skip 64, great stuff. And then you have to say progress bar. What does that actually do? Finish the progress bar and leaves the current message. Okay, whatever. So that gives us this nice progress tracking, which can be useful when you have a long running computation. Let's see if there's anything else. So there's some code layout, don't care about that, we're doing our own. Then there is an exercise. And this is the naive implementation. So this is the this is our basic reference implementation, and we're going to be trying to optimize that throughout this course. But I don't want to do that right now. We'll do that in the next one. So until then,